Unit 5, Day 1 homework tutorial. For questions 1 through 4, we're using this figure at the right. Number 1 would like for us to name a median. Throughout the lesson, we learned that a median must come from a vertex and it must bisect the other side. In other words, it must go through a midpoint. So let's first look for a midpoint. I see that point J is a midpoint because it is in the middle between I and G, indicated by the tally marks. So when I leave point J, I need to go to a vertex. So the only line doing that is HJ. So HJ would be our median. All right. Number 2 wants us to name an altitude. We learned from the lesson that an altitude must be perpendicular with a side, and it must come from a vertex. So when I noticed that at point J you see a right angle, and as I follow it in the other direction, either all the way up or all the way down, it does not touch a vertex. So there's no line there, but there is another right angle at point K. And when I leave point K and go to point I is a vertex. So this would be my altitude because it has to be perpendicular with the side and it must come from a vertex. So IK or KI, doesn't matter how you name it. Now we're going to name an angle bisector. We know from our notes that an angle bisector must split a vertex into 2 equal angles. And therefore, the only vertex that is being split into 2 equal angles is vertex G. So the angle bisector would be GL. And lastly, it would like for us to name a perpendicular bisector. A perpendicular bisector must bisect the side and be perpendicular with the side. So I need to see a right angle and a midpoint. Or, excuse me, a right angle at a midpoint. So we have already established that the only midpoint on the picture is point J. So the line that goes through point J straight up and down forming the 90 degrees is MJ. This line here. Sorry, my highlighting's not straight. Now it is. But MJ. Straight up and down forming a 90-degree angle, and it's going through midpoint J. So we would say MJ. Like Michael Jordan. Number 5 says that PU is a median. So let's highlight PU on the picture. So since PU is the median, we now know that U is a midpoint. So that means TU and UQ are congruent. Then it tells us the distance from U to Q is 6. So this distance is 6. And it would like for us to find the distance from T to Q. P to Q would be this whole thing. So I know that I could say this is part, and this is whole. So we have segment addition, part plus part equals whole. In other words, TU plus UQ equals TQ. I know that UQ is 6, and I know that TU and UQ are the same, so TU is also 6. So now I can find TQ by simply adding 6 and 6, so that's 12. Before I scroll down, let's go ahead and do number 7. Number 7 says that PT is an altitude, so let's highlight PT. An altitude must come from a vertex and it must be perpendicular, so let's draw our right angle box so we don't forget. And it's the altitude of triangle PSQ, so let's highlight that triangle as well. Triangle PSQ. Okay. Then it tells us that angle PTS, so let's trace that one. PTS, it's this angle in this corner. Is 3x plus 24. What is the value of x? So I know that PTS is a right angle, so its measure is 90 degrees. So I know I can take 3x plus 24 and equal it to 90. And then I can find x. So I would first subtract 24. After I subtract 24, you would end up having 66. And then divide by 3 on both sides, and you would have x equals 22. Number 6 says that PS is an angle bisector. So let's highlight PS. And it tells us that RPS, let's highlight that one. RPS. So it's this small angle on the left side. And then it tells us about RPT, which is the larger angle. So we know RPS and TPS have the same measurement. So since they have the same measurement, I can do 2 times RPS, which would give me RPT. So in other words, 2 times 4x plus 7 is going to equal 10x minus 2. Again, because these two angles are the same measure, so instead of adding them, it's easier just to double it. So now I'm going to distribute the 2, and I would get 8x plus 14 equals 10x minus 2. Then I would subtract 8x, which would give me 14 equals 2x minus 2. Then add 2 to both sides, so that gives me 16 equals 2x. And therefore divide by 2, so you would have x equals 8. On number 8, we're told that PT is a perpendicular bisector. Here's PT, and it's a perpendicular bisector of triangle RPQ. So let's trace RPQ. So since it's a perpendicular bisector, we now know that T is a midpoint. It's the midpoint between R and Q. So this distance, RT, equals this distance, TQ. We also know there's going to be a right angle right here. So from R to T, it says it's 9.5. And it also tells us that PTQ is 4x. It would like for us to solve for x. So the RT fact seems to be some extra information that we don't need right now, because x is in the angle PTQ, and since it is PTQ is equal to 90 degrees, we know that 4x is equal to 90. So divide both sides by 4, and you have x equals, what is that? It's not 15 and it's not 20. Is it 25? Or 22.5? Let's double check with the handy dandy calculator. 22.5. Oh, it also had wanted us to find RQ. So there was more to it. We know, okay, we know RT is 9.5, so that means that TQ is also 9.5. So RQ is 2 times the amount of RT. In other words, 2 times 9.5, which would be 19. So we found RQ and we solved for X. So you did need both pieces of information. My apologies. All right. Let's flip it over to the next set of problems I asked you to do. Number 11 says AC is an altitude. So it's an altitude, which means that it would form a 90-degree angle right here. So now that I know that, I know that the measure of ACD is going to equal 90 degrees. So B is a true statement. Number 12. Number 12 is now saying that AC is an angle bisector. So let's re-highlight it again. So since it's an angle bisector, we now know that this angle, BAC, is equal to this angle, CAD. So let's see which statement is true. BAC congruent to DAC. H. There we go. And on number 13, AC is now a median. So since it's a median, C is now a midpoint. So BC is the same as CD. Let's look at our answer choices. That is one of them. D. BC is equal to CD. So on all three of those problems, we were always looking at segment AC, but when it changed titles, its roles and behaviors changed. So you just got to pay attention to how it affects the triangle when its title changes to something different. All right, let's go to the last page. Starting with question 24. We have triangle ABC, and the first question it wants to know is what is the midpoint of A to C? So remember how I demonstrated on the notes? Simply count the rise and the run from A to C. So let's start counting. 1, 2, 3, 4, 5, 6, 7, 8 up. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 across. So to find the midpoint, it would be half of both of those numbers. So that means 4 up. So 1, 2, 3, 4, and 5 across. 1, 2, 3, 4, 5. So the midpoint would be right here at +2, -6. So F. Also, the midpoint formula. For AC, you would say the x for A is -3 plus the x for C, which is 7, divided by 2. The y for A, which is -10, plus the y for C, which is -2, divided by 2. So that's extra work. Both should be shown as evidence to let me know that you understand what you're doing. Either illustrate it on the graph, like I did, or show me the formula. But you have to show something. Just circling an answer is not enough evidence. Number 5 wants to know what is the slope of a median drawn from point A. So in other words, it's going to leave point A and touch BC. But in order to in order to be a median, it has to go through the midpoint of BC. So first we need to find the midpoint of BC. So to find it, I count down 4, 5, 6, over is 2, 4, 6. So the median would be half of both of those, so 3 and 3. I'm sorry, midpoint, sorry. So down 3, bring me here, and over 3 would bring me here. So here's the midpoint, and it is located at 4, 1. So now that I have the midpoint, from A to that point, I could calculate my slope. So I would go up 2, 4, 6, 8, 10, 11, and over 3, 4, 5, 6, 7. So our slope is always rise over run. So I rose 11 and I ran 7. So 11 over 7, which is choice B. So all of that work is necessary in order to get full credit on this answer. You had to find the midpoint and then find the slope between those 2 points. Number 26 wants to know what would the slope be of an altitude drawn from point B. Now, in order to answer this question, you would need to know the slope of AC, because the altitude leaving B has to be perpendicular to that. So first, let's find the slope of AC. So to get from A to C, you have to go up 2, 4, 6, 8 over 3, 6, 9, 10. So that slope for AC is 8 over 10, which reduces to 4 over 5. So the slope for the altitude would have to be the opposite reciprocal because it's perpendicular. So the slope for the altitude would have to be negative 5 over 4. So H. Again, because it has to be an opposite reciprocal. '27 says, what is the equation of a line that contains BC? So to write the slope for this line, the equation, I would need to know what the slope is. The slope of BC, did I find that one already? No, I didn't. So let's find the slope of BC first. So I go down 2, 4, 6. So that's a negative. And go over 2, 4, 6. So the slope of BC is negative 6 over 6, which is simply negative 1. And then I'm going to use B's points to find the y-intercept. Okay, remember this information so I can scroll back down to the exact problem that I'm on, which is number 27. So I have my slope, and I have a point. So I need to use y equals mx plus b. I'm going to replace y with b's 4. I could use c's, it doesn't matter. I'm going to replace m with -1 and x with +1, which comes from b, again, point b. So I can find b, which is the y-intercept. So I would 4 equals -1 plus b. Add 1 to both sides. You would get 5 equals the y-intercept. So the correct equation would be C. Y equals -x plus 5. All right, and our last question, number 28. Oh, no, it's not. Sorry. Number 28 says, what is the equation of a line that contains the perpendicular bisector of AB? So on this one, I got to find the slope of AB and then its opposite reciprocal. So let's find the slope of AB, which I could have sworn we've done this one already, but maybe not. So let's calculate the slope. Oh, goodness gracious. Sorry, I'm having technical difficulties. I can't stop the recording. All right, now it wants to cooperate again. Sorry for that delay. Back to where we were. Calculating the slope from A to B. So, okay. Now my pen doesn't want to cooperate. It's always something, I tell you. All right. 2, 3, 4, 6, 8, 10, 12, 14. So 14 up over 2, 4. So the slope of A to B is 14 over 4, which reduces to 7 over 2. So knowing that, I now know that in order to be perpendicular, my slope would need to be an opposite reciprocal of that slope. So the slope of the perpendicular bisector would have to be negative 2 over 7. So that would eliminate choice G and J. Now, to be a perpendicular bisector of AB, it would have to go through the midpoint of AB. So we also need to find the midpoint of AB. Let's go back to the picture. And we want to use those coordinates to find our y-intercept value. So the midpoint would be up 7. So 2, 4, 6, 7. And over 2. 1, 2. So the midpoint would be at negative 1, negative 3. So I'm going to use that value, or that point, to calculate the y-intercept. Properly. So again, to find the y-intercept, we're going to use y equals mx plus b. We're going to use negative 3 as y because that's the midpoint. M is negative 2 over 7 because that's the correct slope. And then x would be negative 1. And all of this again is to find our y-intercept so we can figure out which is the final correct equation. So we would have negative 3 equal to 2 over 7 plus b. And then I would subtract negative 2 over, I would subtract 2 over 7 from both sides. So it would end up being negative 3 minus 2 over 7. Let's use our fraction skills to get a common denominator. So this would be 7 times 3 is 21. So negative 21 sevenths minus 2 sevenths. So that would end up being negative 23 sevenths. And they have all their answer choices written as a mixed fraction, which is glorious. So that would be negative 3 and 2 sevenths. So our final answer would be H. That one was nasty. I'll admit, that one was nasty. Number 29 says, what is the equation of a line that contains the altitude from point A? So in order to be an altitude from point A, it would have to be perpendicular with BC. So I would need to know the slope of BC, which was negative 1. And the opposite reciprocal of that is positive 1. And where point A is located at negative 3, negative 10. So now I can use all of that information to figure out the y-intercept so I can write my equation. So point A was at negative 3, negative 10. My slope that I'm going to use is positive 1 because it has to be perpendicular again with BC, which has a slope of negative 1. So y equals mx plus b. Going to replace everything except for b. So y is going to be negative 10, m is 1, x is negative 3. So that would be negative 10 equals negative 3 plus b. So I would add 3 to both sides, which would give me negative 7 equals b. So the final equation would be written as y equals x minus 7. And number 30. What is the equation of a line that contains a perpendicular bisector of BC? So if it's perpendicular to BC, it would have to have the opposite reciprocal slope, which we just found out that slope would be a positive 1. And it must go through the midpoint of BC, which is 4, 1. We found that out before as well. So let's write this information down. The midpoint was 4, 1, and the slope would be positive 1. So we're going to use this information to write our new equation. I wrote everything correctly. So y equals mx plus b again. Y is going to be replaced with 1, m with 1, x with 4, so we can find b. So that would be 1 equals 4 plus b. Subtract 4, you would get negative 3 equals b. So the final equation would say y equals x minus 3. Whew, I'm sorry, y'all. This concludes, finally, your tutorial on this lesson.